Hello, welcome one and all to first PUC Tungal online classes. Now in this session we will discuss the important concept of thermal properties of matter. The concept is the radiation. Students, already we have learnt about the modes of heat transfers, conduction, convection. Now let us study about the radiation. Shall we go to the radiation part? Radiation. See here, radiation means the process of transfer of heat from one part to another part without heating intervening medium. This we are calling radiation. Andra one part ದಿಂದ ಇನ್ನೊಂದು ಪಾರ್ಟಿಗೆ ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ಲಿಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ? ರೇಡಿಯೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್, ದ ರೇಡಿಯೇಷನ್ಸ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ದ ಸನ್, ದೋಸ್ ಆರ್ ಕಾಲ್ಡ್ as thermal radiations. I am saying the definition that the process of transfer of heat from one region to another region without heating intervening medium. Intervening medium means whatever the medium comes in between the source and observer, that medium we are calling intervening medium. Shall I the definition of radiation? The process of transfer of heat. The process of transfer of heat. Process of transfer of heat. Transfer of heat from one place to another place. From one place to another place. One place to another place is called as radiation. Is called as a radiation. Without heating intervening medium, I can call. Without heating intervening medium. See here, Prevost theory said that if any body has the temperature greater than minus 273.15 degrees Celsius or 0 Kelvin, those bodies emit the radiation in the form of heat. Those radiations we are calling thermal radiation. For example, the light coming from the sun, those light consist of 7 types of radiation that we are calling electromagnetic waves. From the sun, actually 7 types of radiations are coming out. Among those, infrared radiation is nothing but one of the type of electromagnetic waves. Those radiation, infrared radiation, we are calling thermal radiation, because the wavelength of the thermal radiation lying from 7.8 into 10 raised to minus 7 meter to 4 into 10 raised to minus 4 meter is available. Similarly, we said that any body has the temperature greater than 0 Kelvin, those body emit the radiation in the form of heat. Those radiations I am calling thermal radiation or heat radiations. Those radiations having the wavelength similar to infrared radiation, that's what the thermal radiation we can call the infrared radiation. Shall I call the thermal radiation? The radiation emitted due to temperature of the body, those we are calling thermal radiations. I mean, any body has the temperature greater than 0 Kelvin or minus 273.15 degrees Celsius, those body emit these radiations of the wavelength. What wavelength? The wavelength of the thermal radiation lying from 7.98 into 10 raised to minus 7 to 4 into 10 raised to minus 4 meter. This much wavelength is available. And this thermal radiation has lot of property. The first property of thermal radiation I can call, when this thermal radiation travels from one region to another region, they does not hit the intervening medium. I said already what is meaning of intervening medium. Because when radiation coming from sun to earth, that does not hit the atmosphere. Right? And one thing is that this thermal radiation can affect on the surface. When thermal radiation incident on the surface, these radiation exert a pressure. That pressure we are calling radiating pressure. Shall I call here? I will take it is one surface. This is one surface. Shall I call? This is the surface. Right? When on this surface, consider thermal radiation incident. These are the thermal radiation. Shall I call these are IR radiation? Because IR radiation I can call the thermal radiation or heat radiation. When this radiation incident on the surface, they exert pressure. This pressure I can call radiating pressure. Radiating pressure. Right? And thing is, the intensity of this thermal radiation decreases as the distance from the source of thermal radiation increase. We can call the intensity of thermal radiation inversely proportional to square of the distance from source of thermal radiation. ಹೆಂಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತದ ಈ ಥರ್ಮಲ್ ರೇಡಿಯೇಷನ್ ಇಂಟೆನ್ಸಿಟಿ ಏನಾಗ್ತದ ಡಿಕ್ರೀಸ್ ಆಗ್ತದ. ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ಥರ್ಮಲ್ ರೇಡಿಯೇಷನ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ source of heat radiation or thermal radiation. I mean, when radiations coming from the sun, as gradually distance increase, their intensity decrease. And remember, this thermal radiation always it is blocked by ozone layer. See here. Again, this thermal radiation has lot of properties. The properties of thermal radiation can call, this radiation can travel in the vacuum or in the medium with the speed of 3 into 10 raised to 8 meter per second. See here, how to write? The speed of thermal radiation can say, we can call 3 into 10 raised to 8 meter per second. But remember one important point is, this thermal radiation may or may not require medium for their propagation. ಈ ಪ್ರೊಪಗೇಷನ್ ಆಗಲಿಕ್ಕೆ ಈ ಮೂವ್ ಆಗಲಿಕ್ಕೆ ಮೀಡಿಯಮ್ ಇದ್ರೂ ನಡೀತದ ಇರದೇ ಇದ್ರೂ ನಡೀತದ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, thermal radiation can travel in vacuum, or thermal radiation also can travel in air or vacuum they can travel, or in water also they can travel, in some other medium they can travel. So here again, this thermal radiation can be reflected property, refracting property, polarization property and interference property. These are what? Thermal radiation and few properties of thermal radiation. But look at my students, when thermal radiation incident on the surface, some part of the thermal radiation can be reflected, some other part can be transmitted, and some other part of the thermal radiation can be absorbed. For example, I will take here only. See here. Again I will take, this is one surface. This is one surface. On this surface consider thermal radiation incident. These are thermal radiation. When thermal radiation incident, how much amount? Q amount of thermal radiation incident. When thermal radiation incident, some part of the thermal radiation can be reflected, represented by QR, right? And some amount of thermal radiation can be absorbed. This can be represented by QB, and the some amount of thermal radiation can be transmitted, can be represented by QT. Are you following? ನಾನು ಹೇಳಿಕತ್ತೀನಿ, ಯಾವಾಗ ಥರ್ಮಲ್ ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತದೆ, ಕೆಲವೊಂದು ಪಾರ್ಟ್ ರಿಫ್ಲೆಕ್ಟ್ ಆಗ್ತದೆ, ಕೆಲವೊಂದು ಪಾರ್ಟ್ ಎಬ್ಸಾರ್ಬ್ ಆಗ್ತದೆ, ಕೆಲವೊಂದು ಪಾರ್ಟ್ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಆಗ್ತದೆ. See here. Then total incident radiation can be given. The Q amount of incident radiation can be given. Q is equal to how much? The summation of reflected part and absorbed part along with the transmitted part. Shall I call this equation number 1 now? Right? I can call equation number 1. Now divide this equation by Q on both sides. Divide this equation by Q on both sides. What to do? Simply I will divide by Q value. Here also Q. Similarly here also, and here also divided by Q. Right? Then the Q divided by Q get cancelled, remaining 1. Then how to write this relation? This relation can be written. See here. QR, reflected part, absorbed part plus transmitted part, equal to how much? 1 value. Shall I call this? Or shall I call QR divided by Q, QB divided by Q and Q2 divided by Q equal to 1? Now shall I call this is equation number 2 now? But here we are defining 3 properties. One is reflecting power, absorbing power and transmitting power from this relation. Here what is QR? Amount of thermal radiation reflected when thermal radiation incident on the surface. What is Q? Total amount of thermal radiation incident. This ratio QR divided by Q equal to reflecting power. Reflecting power I can call. Right? Here what is reflecting power? Reflecting power of a surface is the ratio of amount of thermal radiation reflected to amount of heat radiation incident on it. How it is? The ratio of amount of heat radiation reflected to amount of heat radiation incident, this power we are calling reflecting power. Reflecting power. Similarly, this power we are calling absorbing power. Absorbing power. Absorbing power. How to define absorbing power? The ratio of amount of heat radiation absorbed by the substance to total number of heat radiation incident on the surface. This ratio we are calling absorbing power. Similarly, this ratio QT divided by Q is called transmitting power. Transmitting power. How to define transmitting power? The transmitting power of the substance is the ratio of amount of heat radiation transmitted to number of or total number of heat radiation incident on the surface. But see here, from all these relations we can learn which body is perfectly absorbing, perfectly reflecting and perfectly transmitting body. See here, mirror, it is completely reflecting body. And black body you can call completely absorbing body, completely absorbing power body. And transmitting body you can call the glass. The glass is a perfectly transmitting body I can call, nearly. See here, from all these relations you can learn which is the perfectly reflecting, perfectly absorbing and perfectly transmitting. The body is said to be perfectly reflecting. When we are calling perfectly reflecting, if these two quantities must be 0. I mean, shall I write this relation? See here, if the case, I will write in alternating manner this equation. How to write? QR divided by Q. Shall I represent QA or QA I can call? See here, QR divided by Q. Shall I call it is A or R I can call reflecting, plus QB divided by cube. Shall I call it is B? QT divided by Q. Shall I call T equal to 1? Where R is reflecting power, B is absorbing power and T is transmitting power. From this relation you can learn. See here. In this equation, if absorbing power and transmitting power both are 0. Absorbing power and transmitting power both are 0. Then what about this from this equation? Shall I call from this R equal to 1? R equal to, I mean, the body is said to be perfectly reflecting if there is no absorbing power, there is no transmitting power. Right? Similarly, see here. Now I will take the body is said to be completely transmitting body. When we are calling transmitting body, if reflecting power and absorbing power both are 0. Reflecting power and absorbing power both are 0. Then how to say? Then T is equal to how much? T is equal to 1. The body should be perfectly transmitting body. Glass can perfectly transfer, not all type of glasses. Some type of glass they can completely transfer to the radiation. See here, perfectly transmitting body. Then when we are calling perfectly absorbing body, when we are calling if there is no reflecting power, no transmitting power, then what about B? B equal to 0. Sorry, B is equal to 1. B equal to 1. When the body absorb all the radiation, that body we are calling perfectly absorbing body. Or the perfectly absorbing body also we can call the black body or perfectly black body. Shall I go? In this case, what happened? There is no transmitting power, there is no reflecting power. Whatever amount of heat radiation incident on the surface, all the radiation of all the wavelength must be absorbed by the body. That body we are calling black body, or that body we are calling perfectly black body. Shall I go the concept of black body? Now directly from this equation you can know the concept of the black body. Remember, say here, directly I will go for black body. Look at me. Black body. See here, students, we know that the color appearance of the body when body heated at different temperature. Initially when body heated, the color looks like yellow. When temperature of the body increases, the colors appears blue. Then after reddish blue, different colors of the body can occur because the body emitting of different wavelength. I mean, the body is appeared to be color because it emit a definite radiation of different wavelength. But in black body what happens? The body which absorb all radiation of all wavelength incident on it, that body we are calling black body, and the black body does not radiating, does not reflecting any amount of radiation. So this body looks like a black. Simply I can call black body mean the body which absorb all radiation of all wavelength incident on it, that body we are calling perfectly black body or black body. Shall I go? Definition here. The body which absorb, the body which absorb, absorb all radiations of all wavelength, incident on it, such body is called as black body. Such body is called as black body. But in the nature there is no perfectly black body, even though the Ferri constructed nearly perfect black body. Let us go how the black body, Ferri's black body looks like. The Ferri's black body consists of double evacuated spherical cavity, inside which it is blackened and evacuated. Evacuated means it is constructed in such a way that there is no allow of heat loss from this body. That body we are calling perfectly black body or Ferri's body. Shall I see how the Ferri's black body looks like? See here, Ferri's black body. Ferri's black body. See here, Ferri's black body consists of a double walled evacuated spherical cavity. Double walled evacuated spherical cavity. See here, like this. This we are calling perfectly black body. There is small cavities made to allow the thermal radiation. See here, the double walled spherical insulated cavity, this we are calling perfectly black body. Inside it is evacuated to reach us, there is no loss of it from it. Here what happens? When thermal radiation incident thermal radiation incident at one side, I mean IR radiation incident at one side. This radiation get multiple reflected inside. Multiple reflected. As a result, there is no loss of heat. Multiple reflected in such a way that there is no loss of heat. But students, I said that black body mean the body which absorb all types of radiation of all wavelength incident on it. But when black body heated to a suitable temperature, it emits the wavelength of all possible values. ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ ಅಂದ್ರೆ ಯಾವ ಬಾಡಿ ಎಲ್ಲ ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ಕೋತದ ಅವನ್ನೆಲ್ಲನೂ ಎಬ್ಸಾರ್ವ್ ಮಾಡ್ಕೋತದ ಅಂಥ ಬಾಡಿ ನಾವೇನು ಕರಿತೀರಿ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ ಅಂತ ಕರಿತೀರಿ. ಅದೇ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿನ ನೀವು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೆಂಪ್ರೇಚರ್ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಅದು ವ್ಯಾವಲೆಂತನ್ನು ಎಮಿಟ್ ಮಾಡ್ತದೆ, ಅದು ಕಲರನ್ನು ಎಮಿಟ್ ಮಾಡ್ತದೆ, ಎಲ್ಲ ರೇಂಜದ ವ್ಯಾಲ್ಯೂಗಳನ್ನು ಎಮಿಟ್ ಮಾಡ್ತದೆ. ಐ ಮೀನ್ if the temperature of the black body increases gradually, the energy emitted by the black body is more at a different wavelength. Now let us see how the energy is emitted by the black body at a different temperature. At different temperature, the black body emits the different wavelength of different amount of energy. Generally, when black body heated, its temperature rises. When temperature rises, the black body can be emitted energy per unit area, per unit time of different value depending on wavelength, depending on temperature. If the temperature of the body increases gradually, energy emitted by the black body also more. At different temperature, what is the energy emitted by the black body and wavelength, that we will see now. See here, let us consider this black body heated. It emits the different amount of energy at different temperature, I said. Look at me. I will take along x-axis, I will take the temperature I will take, and along y-axis I will take the energy. Initially when the temperature of the black body increases, the energy emitted will be maximum at a particular value. Then after, energy emitted by the black body decreases. For different temperature, the energy emitted by the black body can be shown like this. See here, at a different amount of temperature, the energy emitted by the black bodies are different. Energy emitted by the black bodies are different. Shall I take here? Like this, can go like this. See here, at a particular temperature, all the thermal radiation having maximum amount of energy. At this temperature, maximum energy. Again at this temperature, there is maximum energy. At this temperature, there is maximum energy. At a maximum energy, the wavelength must be maximum. Initially what happens? When temperature of the black body increases gradually, energy is increased at a particular temperature, at a particular wavelength. The energy of this black body is maximum. I mean, the characteristic property of the black body is when the temperature of the black body increases, definitely energy also increase. At a particular temperature, the energy of the body emitted must be maximum. For example, at this temperature, at this wavelength, energy of the black body is maximum here. Here also maximum. Look at me. At this point, there is maximum temperature at this 10. But after reaching some amount of temperature, again the energy of the black body decreases. Exactly at a very low temperature and very at a high temperature, the energy is not same. At low temperature, energy is minimum. At high temperature, energy also minimum. At intermediate temperature, the maximum energy can be emitted by the black body. And the energy distribution is not same. At a very low temperature, at a very high temperature, the wavelength of thermal radiation must be decreases. See here, at a very low temperature and very at high temperature, the wavelength of the energy of the thermal radiation must be changes from minimum to maximum. We said that as the temperature increases in black body, the wavelength of the black body radiation must be decreases. One thing. And second thing is, if the temperature of the black body increases, what we are saying, energy emitted by the black body per unit area, per unit time must be maximum at a particular value. Depending on that, we are going to discuss two famous laws concerned to energy distribution for the black body. One is the Stefan's law and second one is Wien's displacement law. Shall I go? First one is the Stefan's law. Stefan's law. Stefan's law. See here, what you are saying? When the temperature of the black body increases, at a particular temperature, the energy of the black body is maximum. On this basis, we are going to say the statement of Stefan's law. The Stefan's law says that the energy emitted per unit area per unit time by the black body is directly proportional to fourth power of temperature of the body. Shall I go here? What the statement of Stefan's law? The energy emitted by the black body per unit area per unit time directly proportional to fourth power of temperature of the black body. This is the statement of Stefan's law. I mean, more the energy, more the temperature of the black body, lesser the energy, lesser amount of temperature of the black body. Or can call energy emitted per unit area per unit time is equal to some constant E into sigma, where E we are calling emittivity of the black body. Sigma represents Stefan's constant. Shall I go sigma first of all? Sigma is constant. This constant we are calling Stefan's constant. Its value is 5.67 into 10 raised to minus 8 watt per meter square per Kelvin. It is constant. And emittivity, emission power of the black body, it depends on nature of the black body. It lies from 0 to 1. See here, it lies from 0 to 1. And for perfectly black body, its value is 1. Right? Simply Stefan's law says that the energy emitted by the black body is directly proportional to its temperature. See here, again this Stefan's law you can modify. If the case A represent area of this body, A represent area of the black body, then energy emitted per area can represent, or energy emitted due to area of the body can represent. Shall I take here? Energy emitted by the black body in a given area. Shall I take this equation? If area is given, then I can represent A E sigma T raised to fourth. Right? Where A represent area of the black body, E represent emittivity, sigma represent what? Sigma represent Stefan's constant. Right? But again this equation you can modify. See here, what is the T represent temperature of this black body due to increase in its energy. If T naught represent the temperature of surrounding, T naught represent temperature of surrounding. Again this equation you can modify. How to modify? This equation you can modify is equal to A, keep it up same, E also sigma all are constant. Then this I can represent like this. T represent temperature of the black body, T naught represent temperature of surrounding. Either you can write in this way, you can write the Stefan's law, you can write in this way, or you can write in this way. Similarly, you can represent like this also. Right? This is one law concerned to energy emitted by the black body. Now, let us see the one more law. That law we are calling Wien's law. See here. Second one I can call Wien's law, or Wien's displacement law can call. Wien's law. Wien's law. See here. Wien's law says that if the temperature of the black body gradually increase, its energy increase. When energy increase, the wavelength of the black body changes from maximum to minimum, from longer to shorter wavelength. Initially temperature increase, let us consider wavelength is 7.8 into 10 raised to minus 7 meter. Gradually when temperature increase, the wavelength of the black body emitted by it will be decrease. I mean, the wavelength corresponding to maximum intensity emitted by the black body is inversely proportional to temperature. Are you following? The wavelength emitted corresponding to maximum intensity by the black body is inversely proportional to temperature. This law we are calling Wien's law. ಅಂದ್ರೆ ನೀವು ಹೆಂಗೆ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ ಹಂಗೇನಾಗ್ತದೆ ವೇವ್ಲೆಂತ್ ಆಫ್ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ ಏನಾಗ್ತದೆ ಡಿಕ್ರೀಸ್ ಆಗೋತೆ ಬರ್ತದೆ. ಹೌ ಮಚ್ ಟೆಂಪ್ರೇಚರ್ ಅಗೇನ್ ರೈಸಸ್ that much again wavelength will be decrease. See here, the wavelength changes from longer to shorter due to increase in energy and due to increase in temperature. On that basis, shall I the Wien's law statement? Wien's law statement says that the wavelength corresponding to the wavelength corresponds to maximum intensity corresponds to maximum intensity inversely proportional to maximum intensity of radiation maximum intensity of radiation is inversely proportional to temperature. Inversely proportional to temperature, that is the wavelength emitted at a particular maximum intensity inversely proportional to temperature, or the wavelength emitted by the black body equal to some constant divided by temperature, where constant b, this constant b you can call the Wien's constant. Its value is 2.898 into 10 raised to minus 4 meter Kelvin. 2.898 into 10 raised to minus 4 meter Kelvin. I mean whatever amount of energy emitted at a particular wavelength at a particular temperature, it is inversely proportional to temperature. How much energy increase, that much wavelength will be decreased. Because when temperature increase, energy also increase. When energy increase, definitely what happens? Wavelength is decreased according to Wien's law. Right, students? But here already I said that thermal radiation does not pass us through atmosphere. Only the visible part of the electromagnetic radiation they can pass us through atmosphere. But some gases, some materials in the atmosphere can able to increase the temperature, because every body its temperature greater than 0 Kelvin, what happens? It emits the thermal radiations, or whatever amount of radiation coming from the sun they can absorb in the atmosphere. See here some gases are there: nitrogen oxide, carbon dioxide, chlorofluorocarbon, and along with methane. All these gases we are calling greenhouse gases. These gases absorb some amount of radiation and increase the temperature of the earth's surface. Thus we are calling global warming. Here we are defining one quantity that we are calling greenhouse effect. Simply the greenhouse effect is the process of increasing temperature of the earth's surface due to increase in greenhouse gases. That phenomena or this process we are calling greenhouse effect. See here, due to human activity in the atmosphere, so many dangerous gases are available. We know the carbon monoxide, nitrogen oxide, carbon dioxide, you can call methane, you can call chlorofluorocarbon, right? All these are materials, they can absorb the thermal radiation, they can absorb the infrared radiation. These gases can able to increase the temperature of the earth's surface. I mean they can only absorb, not having the capacity to live. Due to absorbing, the temperature of the surrounding will be increased. That process we are calling greenhouse effect. Shall I define a greenhouse effect? Greenhouse effect mean the increase in temperature of the earth due to greenhouse gases. See here, greenhouse effect. Greenhouse effect How to define? The process of increasing temperature of the earth. The process of increasing temperature of earth. Increase in temperature of earth. Temperature of earth. By absorbing IR radiation, infrared radiation, or you can call thermal radiation, by greenhouse gases, by absorbing IR radiation by greenhouse gases. This process we are calling greenhouse effect. See here, the greenhouse also helps to human activity. Greenhouse means above 0 Kelvin, the temperature of the earth is increased and the human activity only changes at this temperature. This is one of the use only, but due to greenhouse effect, the global warming is possible. Due to that, the temperature of the earth changes from 0.5 to 0.6 degrees Celsius per year. Hence that per decade, the temperature of the earth may changes from 1 degree to 2 degree, depending on the activity, the dangerous gases which are restored in the atmosphere. So this is concerned to the greenhouse effect and the radiation. Students, up to here, the theory part concerned to thermal property of matter is over. In tomorrow's class, we will discuss concerned to NCERT numerical. Then after that, we will go for the coaching part. Thank you.